A very good afternoon to all of you. Today we are going to be discuss how to analyze a data in SPSS. Our topic is on test for single mean. Before explaining about test for single mean, I would like to take a note. What is single mean? The test for single mean, it's about to the parametric tests, and here you have two types of samples. One is large sample, another one is small sample. Generally, when the sample size is more than or equal to 30, we treat it is in a large sample proportion. When you come to when the sample size is less than or equal to 30, sorry, less than 30, we consider as a small sample. Even now, I am taking an example today, explain about the test for single mean in a small sample case. The question is here, a fertilizer mixing machine is said to give 12 kg of nitrite for every quantile bag of fertilizer. They are examined 1000 kgs bags. It means every quantile is called as a 100 kgs. I mean every 100 kgs, 12 kg of nitrate will be mixed into the fertilizer to grown of a particular seeds or to get some good yield. For that we apply the fertilizer, and in the fertilizer the nitrogen like nitrate component is most important. Now we have taken a sample of 9. We have taken a sample of 9 bags and we have tested that, and we have the results has been displayed over here, like 11 kg, 14 kg, 13 kg, 12 kg, 13 kg, 12 kg, 13 kg, 14 kg, 11 kg, 12 kg. In this the way the machine was mixed the fertilizer. Now we wanted to verify whether the machine is mixing properly or not. Okay. Any testing of hypothesis process, we need to frame the hypothesis. We know generally there are two types of hypothesis. One is simple hypothesis, the other one is composite hypothesis. Under the simple hypothesis, we have two types of hypothesis. One is null hypothesis, the other one is alternative hypothesis. The null in the sense, whatever you say, it is accepted. That is called null. Okay, like if the machine is working properly, that is null. The machine is not working, alternative. This is the way we prefer the simple hypothesis, and we can take the composite also. Whether the machine is mixing less than or equal to 12 kg or greater than or equal to 12 kg. If you are asking like that, then we can say that the machine is mixing properly or not. Now, we will frame the hypothesis first, then we will explain this in the SPSS software. Now, let's see all of you. Now the hypothesis. See the hypothesis. What is that? The machine mixing the fertilizer of a nitrate is 12 kg of every quintal bag. I'll repeat it. I have framed the hypothesis based on the question. What is that? The machine mixing the fertilizer of nitrate is 12 kg of every quintal bag. This is a very clear-cut hypothesis frame which is asked in the question. But here the machine is not defective. The machine is not defective. Like you can write like this also. Okay, the machine is, sometimes you can write like this also. The mission is working well. The mission is working well. Like that also you can define. And next, alternative hypothesis. The mission mixing the fertilizer of a nitrate is not 12 kg. Alternative means what? Is not happening. Okay, alternative means what, ma? He is not happening. 12 kg of every quintal bag. Or the mission is defective. The mission is defective. See, the hypothesis framing, you can frame as you feel. According to question, you can prepare the hypothesis. According to the question, you can prepare the hypothesis. Even now, I can prepare one more hypothesis. Null hypothesis. Stated like this. The average amount of nitrate mixing into the fertilizer is 12 kg. What I said, ma? The average amount of nitrate mixing to the fertilizer using a machine is 12 kg. We can write like that also, guys, because we are using mean. Test for single mean because we are taking the average value. Is that clear, all of you? Yeah, fine, good. Now this is the way we frame the hypothesis. Now we'll move on to the SPSS window. There we learn, there we how to enter the data. Okay, I'll go to SPSS now. Now I have taken an SPSS window, and everybody knows the SPSS window has two main windows. One is the data editor window, the other one is output viewer window. Under data editor window, we have two views. The one view is called data view, which is looks like an Excel sheet. It is not Excel sheet, it's a spreadsheet. The spreadsheet consists of rows and columns. But in our SPSS, the column name, we call it as a variable. Now we are moving on to the variable now to create the variable. Okay, now what is there in question? Question is about the nitrate. Let me write about the nitrate first. Yeah. In the variable window, what are the name you are typing? You are not supposed to put any space or any symbol because it is a case character free name. You are not supposed to give. For the what you can do, you can put into the label. Under the label, you can type fully. How do you type fully, sir? Like, what is the question? The amount of nitrite mixes into the fertilizer. You can write like that. What we can write, ma? The amount of nitrite. I will repeat. You can type it like this. You can type in the label. Amount of nitrite mixing into the fertilizer. Mixing into the fertilizer. Mixing into the fertilizer. Okay, good. Now you have made like this. And under the variable u, again I'll repeat. First you enter the name, what you are entering. You can write values also. And you have to see the variable type. First of all, we are using parametric test. Whenever using parametric test, it has a measurable one. It has a measurable one. We are measurable like t-test for single mean. Therefore, the data must be the numerical one. And the width, column width can be 8 and decimals. In our data, we don't have any decimals. Therefore, we'll make it 0. And now, then go back to the data view. We enter the data. Okay, what is the data here? What is the data here? That is 11, 14, 13, 12, 13, again 12, again 13, 14, 11 and 12. See, there are 10 samples are given to us. Yeah, there are 10 samples we have taken into the consideration. we have entered the data, how you enter into the Excel. Now, then you go to the analysis part. First, go to analyze in the menu bar session. Under the data editor, we have a menu bar. The menu bar consists of analyze. Under the analyze, you have to click on the compare means. Under the compare means, you have one sample t-test. Because it is a small sample data, no, we can choose that point. And now we have a new window. The name is one sample t-test, and transfer the variable into the test variable, and you can go to the options. There you can fix at what percent level of you are comparing, whether you are verifying at 95% level or 99% level. That is called comparison. But the level of significance is 5% or 1%. The level of significance is 5% or 1%. Now I am taking 95%. It's a usual format. Continue. Now you have to give the test value. What is your test value? The average amount of nitrite contained in the quantile bag is 12 kg. Therefore, every bag consists of 12 kg amount of nitrite. Therefore, in the test value, you put 12. There is another dialog box consistence of the test value. You have to type the what average value you are verifying. Which value you are verifying, you should enter. Then click OK. Now you get an output window. Now you have an output window, guys. Yeah. In the output viewer, you can observe the two tables. The first table states about the descriptive statistics of the data. What is descriptive statistics? Generally, whenever we say descriptive statistics, we will look into the three major components. One is measures of central tendency and measures of dispersion, nature of the distribution. But usually, we don't talk everything inside in the measures of central tendency, dispersion, nature of the distribution. We usually consider only the how many samples you have taken, that is called capital N. And you don't get confusion, guys. In SPSS, the capital N stands for number of samples. Generally, we say that capital N is for population size. Small n is for sample size. But here we can take it into capital N defaultly given in the SPSS. Then we have the average value of the sample. I have sample of observations, 10 observations I have. I have entered the value is 12.50. Then it's what is the standard deviation of the sample? That's 1.080. And next, standard error of mean. But these are the basic descriptive statistics given into our data. Second table is called one sample test. Second table is what? One sample test. There you can see the test statistic value. That's called T value. Then DF. DF stands for degrees of freedom. For example, you have 10 values, 10 samples. The degrees of freedom will be 10 minus 1 for one sample t-test. And then your significant value. What is that, ma? Significant value. In generally, while we are calculating the manually, we usually compare our test statistic value with the table value. But when you come to the digitally, like using some applications like SPSS, Excel, and so on, we compared with significant value. Test statistics value compared with what, ma? Significant value. Here the significant value is what? We compared with to the P value. We compared with what? P. P value is probability value. P value stands for what, Mandi? Probability value. Okay. Now, from this table, the significant value is 0.177. 0.177. I am not supposed to say 77. We have to call it as 0.177. Why? Every indication about like after decimal, you have to call individually. Do not call combinedly. Like not 177. That's wrong pronunciation, guys. Okay. Now we will make the conclusions based on the SPSS table. Based on the SPSS table, we'll make it conclusions. How we make the conclusions? Okay. I'm writing the conclusion. In general, significant value within bracket, we call it as a p value. What do we say, ma? It's a p value. Next, how to make it, sir, p value? Let's see. If p value is less than 0.05, we reject the null hypothesis. We reject the null hypothesis. Okay. If p value is greater than 0.05, then we accept the null hypothesis. Okay. Based on these two statements, our analysis table, the significant p value is 0.177, which is greater than 0.05. Therefore, we reject the we accept the null hypothesis. It means that the whatever the null hypothesis you are taken, that has to be retained. Is that clear, guys, what I'm saying? Yeah. Now what is that? Your p value has to be retained, saying that the average amount of nitrite mixing into the fertilizer is 12 kg. Is what, ma? 12 kg. Thank you.